Okay, here's an example that we didn't have time to do in class, which is changing from a rectangular equation into polar. And remember, our bag of tricks is kind of limited, which is nice because you don't have a lot of choices. Um, X's goes with your cosine, and again, it's multiplied by r because you're not necessarily on the unit circle. And then y goes with sine, and again, there's our r because it could be proportionally bigger than 1. And then r squared equals x squared plus y squared, again, is the format that's helpful. Typically, we think of, like getting the hypotenuse, but again, that doesn't really help you having that square root thing when you're converting. So we squared, and that looks better. So this is about your only choices. So the nice thing is there's not a lot of decisions to be made here. So 4x is the same as r cosine theta in polar. Y is the same as r sine of theta. And then we have equals 9. And so I'm going to multiply here. So I get r squared cosine theta sine theta equals 9. And if I want to simplify this even more and make it look a little bit prettier, these two together with a 2 is one of our trig identities. So I'm going to break this 4 into 2 r squared and then put that other 2 over here by my cosine theta sine theta. And that guy, as long as I have the 2 with it, that's sine of 2 theta. And again, that's one of our trig identities. So that's probably a little nicer looking equation. So again, this is a polar equation because, again, it has theta and r's in it. And so that's all it is.